Hello everyone, welcome to Learn DSA Daily. Today we'll be looking at few questions on modular arithmetic. Let's look at the first question. It's about largest coprime divisors. So we have been given two integers, a and b. And we need to figure out a value x so that a mod x is 0 and x and b are coprime. That is GCD of this b and the value that we have derived is 1. So let's look at the solution. So we'll call a function and pass both the values. We'll declare the function fun. And for calculating the GCD, we'll create another function. What we will do, here we'll run an infinite loop. It's not an infinite loop. We will just run the loop without any condition. And then we will assign a variable g and call the method GCD, both the values. If g comes out to be 1, we will break the loop, and otherwise we will just divide the a with the GCD. Then we will return a. Now let's declare another method GCD. For GCD, we have this formula. So what the GCD formula is, we will assign A with B and we'll assign B with A mod B. And we will keep doing this until B becomes 0. And once B becomes 0, the A that we get is the GCD of both the values. So this is how we calculate GCD, right? Now let's run this and print this. So now we get 5. So how we are getting 5? We have 30 and 12. We pass the 30 and 12 to this function. Then the GCD of 30 and 12 came out to be 6. Now G is not equals to 6. So we did A mod G, which is 30 divided by 6 equals to 5. Right? So our A became 5. And now again, second time we have passed 5, 12 to the GCD. Now 5 and 12 does not share any common factor. So the GCD of 5 and 12 would be 1. And the moment we got 1, we break out of this loop. And then once we broke out of this loop, we return this A. The A was 5. So the 5 got printed. So if you see now, 35 divides 30, leaving remainder 0. 0 and 5 and 12 are coprimes, right? So this is how we can approach this problem. Moving on to the next question, just counting number divisor game. So let's look at what the question says. The question says we need numbers which is less than and equal to 8 that are divisible by both A and B and C, right? So let's look at the implementation. Let's take the number A equals to 12, B equals to 3. and c equals to 2 and call this function. I'll declare this method. Now what we will do is we'll first calculate the LCM of B and C. Then return it and divide A with the LCM. Right? Now for calculating the LCM, we will create another method. Right. Now the formula for LCM is A into B GCD of A and B. And now again we will write the method GCD, which is same as the previous one. While B has value, we will keep reassigning and return A once B becomes 0. If we now run this, okay, print it. So the value is 2. So how it is 2? If if A should be divisible by both B and C, if let's take the example, let's say we have A equal to 6. So when will 6 be divisible by 3 and 2? So if we take the LCM of 3 comma 2, it will come out to be 6, right? So if the LCM of B and C divides A, that means B and C both divides A, correct? So the LCM of B and C was 6, and we had to count the number of values that can divide A. That would be 6 and 12, because our value is 12. So 6 can divide 12 and 12 can also divide 12, which is both divisible by both B and C, right? This is why 2 is the output. So 6 and 12 are two values, right? Let's look at the next question. Is mod sum. Modular sum is, we are given an array 3, right? We need to print the output, like every possible I with every possible j. We need to find the mod, correct? So for all possible values of I and for all possible values of j, we need to figure out the mod and sum it. So it is summation of I mod j for all possible I and j, right? And we don't want the value to be too large. So what we will do, the final output, we will divide it with 10 raised to the power 9 plus 7. It is just given in the question. So this we are just copying from the question. Let's create the function. We create our method function. And here we will declare a mod, right? Now what we will do, also we have a constraint that A will not exceed 1000. So what we can do this using bucket sort or count sort. Sorry, count sort. So for count sort, what we will do, we will create a frequency array and initialize it with 0. And the max value could be 1000. So we will create the frequency array for 1001, max value plus 1. And then we will iterate over for x in each value of a, and frequency we will keep updating. Now we will initialize our answer with 0. And then for each possible I and j pair, we need to figure out. So how we can do it using nested loops. So first we will run a loop for I. So that is for x in range okay. If frequency of that particular number is 0, we will just ignore it. Let's say the frequency of 4 come out, but the 4 is not there in our array, so we will ignore it. Continue. And then again we will run another loop. Of 1. And we'll do the same check. If frequency of y double equals 0. If so, we will continue. And then what we'll do, the answer will add with the current answer that we have. And then x mod y, right? And the number of times x happened into the number of times y has happened. And then do a final mod. And after that, we will just return our answer. So let's run this and see. Okay, we need to print it. B is not defined. So the answer came out to be 5. Now, how it happened? Let's see the example. We did a summation of 1 mod 1 plus 1 mod 2 plus 1 mod 3 plus 2 mod 1 plus 2 mod 2 plus 2 mod 3. And same we did for the third element, right? P mod 1, 2, 3. And all the summation came out to be 5. Right? So this is how we can do this. Let's moving on to the next question. It is remove one element and find the max GCD. We are given an array of integers 12, 15, and 18, right? So let's say we remove 12. Then the GCD of 15 and 18 is 3. Now, if we remove 15, then GCD of 12 and 18 is 6. And if we remove 18, then GCD of 12 and 15 is again 3. Now, among all the 3 GCD that we have, the maximum one is 6. So our output should be 6. So let's see how we will approach this question. And print it and declare this one. So how we can approach this question is we can create a prefix and a suffix sum. And we want to the sum. Instead, we will create the prefix GCD and postfix GCD, suffix GCD. Let's see this. How we'll do it. Calculate the length of A, and then we will have one prefix array and one suffix array. Prefix for first element, we will initialize it to 0, not 0. A, 0th element of A, because GCD of 12 would be 12. And similarly, GCD of 18 would be 18. So similarly, for suffix of last element n minus 1, we will initialize it with the last element. Right? Now let's calculate the prefix and suffix. So what we are doing is GCD, let's say we reach the second element 12. So what we will do, the prefix of I is 1. So for prefix of 0, GCD of only 12 would be 12. Okay. The GCD of 12 and 15, for calculating that, we are calling this method GCD, sending the previous value, I mean the GCD calculated till previous value plus the current value which we having, which is 15. So GCD calculated till 12 plus the current element will give us the GCD till now, till that element, right? And for the suffix, we will do the same, but this suffix we will run from the reverse because we are in prefix, we are adding GCD like for first element we are calculated 12, for 15 GCD of 12 and 15, for 18 GCD of 12, 15, 18. Okay, and for suffix we are going in reverse direction. So for this element GCD will remain 18. For the second element it would be the GCD of 18 and 15, and for the first element it will be the GCD of all. So we are going in the reverse direction, and suffix of I would be GCD of suffix right. The next value. Okay, so suffix I plus 1 means if we are here 15, the suffix we will take this element which is I plus 1 plus this element which is AI. This is how we will calculate it, and then we will initialize our answer with 0. Now we will run a for loop. If I is 0, then GCD would be suffix of 1. So what we are doing here, let's complete it and see. So what we are doing here, we have created a prefix and postfix array. Okay, but in prefix array, we are starting from here and we keep calculating GCD to that point. So for 12, we have GCD till here, then till here, then till here. For suffix, we are going in reverse, right? Now, after we have created prefix and suffix array, we will again iterate over each element of A, okay? And if I equals to 0, so that is GCD till here. So the GCD till here is GCD till 12. What would be the GCD till 12? Would be the GCD of 15 and 18. That means we are excluding 12. Okay. And else if I equals length minus 1. So when we are here, we are excluding 18 and then we are calculating GCD of 12 and 15. Okay. And if we are somewhere in between, then what we will do in the else condition, we will calculate the GCD of prefix I minus 1. So while calculating what we did, prefix from prefix we will take this element 12 and from suffix we will take this element 18 and then calculate the GCD. Okay. And whatever GCD we are getting, we are comparing with it with answer, and whichever value is maximum, we are assigning it to answer. Right. So the biggest value. So in the first iteration, our answer will be 3 because answer was 0. And then we calculated after removing 18, we calculated 12 and 15. And it came out to be, sorry, we removed 12 and for 15 and 18, the GCD came out to be 3. So we assigned it to 3, answer to 3. Then we removed 15 and for 12 and 18, our GCD came out to be 6. And then we compared, answer is 3, G is 6, max value of both is 6. So we assigned it to the answer. And finally it remained 6, so we returned the answer. Okay, now let's also create the GCD method. And again, we have the same formula, while B. While B has value, we will keep reassigning it. A will assign B, and for B, we will assign A mod B. And once B becomes 0, we will return A. Right? So let's run this. So if we see now, our output is 6 because the GCD of 12 and 18 is 6 and we returned maximum value. Right? That's all for today. See you tomorrow. Thank you.